Here we go for a warm-up today. On number 1, you'll notice that we have a pair of opposites, or of a positive and negative, but the numbers don't match. So yesterday we learned that with elimination, we can make a match. So we're going to take this bottom equation and multiply it by 3 in order to cancel out the x's. Now, we learned yesterday there's more than one way to do that. You could also have multiplied the y's each by something in order to cancel those out, but this would be the easier method. So my recommendation would be to multiply this one times 3 to make one a positive 9 and one a negative 9. So I'm going to rewrite the first equation. That didn't change here. The second equation, when I multiply it by 3, I get negative 9x plus 24y equals negative 51. Since these x's are now opposites, they're going to eliminate. 3y plus 24y makes 27y. Negative 3 plus negative 51 is negative 54. Divide by 27. Y equals negative 2. So now I choose which equation I want to plug that back into. The first one has more positives, so I'm going to choose that one. You also could have chosen the second one. So I have 9x plus 3 times y, and y is negative 2, equals negative 3. So I have 9x minus 6 equals negative 3. Add 6. 9x equals 3. Divide by 9. Well, 3 divided by 9, we can write that as 1/3. So my ordered pair, my solution, would be 1/3 and negative 2. Number 2, again, we're looking for a pair of opposites. Well, we have a couple of choices here. Here, I could make my x's match by only multiplying one line, but since they're both positive, I would have to multiply by negative. The y's are already opposites, but to make a 3 and a 5y match, I would have to multiply both equations by a number. Both methods are absolutely correct. I'm going to choose to do the least work, which means I'm going to multiply this top one by negative 2 to make the x's cancel. If you took care of the y's, you should still end up with the same answer at the end. So I'm going to bring this equation down here. So I have negative 4x minus 6y, because again we're multiplying by negative 2, equals negative 12. Add them together, x's eliminate. Negative 5y plus negative 6y is negative 11y. Negative 20 plus negative 12 is negative 22. Divide by negative 11. Y is a positive 2. Going back to either equation to see which one I want to plug it into. Top one has all positives, so I'm going to choose that one. So I have 2x plus 3 times y, which is 3 times 2, equals 6. So now it's 2x plus 6 equals 6. Subtract 6. So 2x is equal to 0. Divide by 2, which means x is still equal to 0. Remember, 0 is an answer. It is not no solution or infinitely many, as long as you have variables in the picture. So our answer is 0, 2. Hopefully you did well on both of these. Again, you could have also done different methods as long as you ended up with the same answer. This is the work you were working on in class yesterday. You could have checked them as you went along or waited until today to check your answers. Number 7 was 1, negative 5. Now, this is just one way that you could have done it. This is the second way. So I gave you both options. Number 8, I would recommend multiplying the second one by 3. No, it's not the only method, but that one would be the easiest one. Number 9 and 10, I gave you different options. You could have multiplied the first equation by 5, which means you would then multiply the second one by 3, or multiply by 3 and by 2. And then you can see that I chose the 5 and the 3. Number 11, since that one's shown already, to eliminate y, you'd have to multiply by a -4 and 11, or you could multiply by a +4 and a -11. To eliminate the x's, 3 and 2, and one of them has to be negative. Number 12 is writing that expression. I called my hamburger x's and my hot dogs y. There were 12 packages, and then the cost of the hot dogs, the hamburgers, and the total price paid. Number 10, different options that you could have picked. Here, because of the fact one of them had to be negative, it kind of added on to the possibilities that you could have done. So you could have multiplied by a -3, which would have meant multiplying the other one by a +5, or you could have made the 5 negative instead, or you could have chosen to multiply by 7s and choose to make your y's match. 13, that was a bit harder of a problem. You had 2 angles, and you knew that 3 times, so there's the 3x, is 30, and is your equal sign, 30 more than 5 times angle 2. So 30 more than is plus 5 times angle 2. The second equation said the sum, which means you're going to be adding, of twice each angle, so 2x and 2y, is equal to 180. Now with this one, I chose to move the 5y over so that I could line them up. You could have divided by 3 to get x by itself, but then you would have had a fraction. So once I lined them up, which is right here, I noticed that it would be easy to eliminate my y's since they are already opposites. It would just be a matter of making them the same number. And that's this process right here. 6x minus 10y equals 60, and then 10x plus 10y equals 900. I then got an answer of x equals 56.25, so I chose the second equation to plug that into to solve for y of 33.75. 14, these equations were a little bit easier. 3a plus 2b equals 16, or 2a plus 3b equals 14. And then B, the shelf B, each thing was 2, and shelf A, each was 4. So how much more does an item on shelf A cost? It costs $2 more. 15, they kind of tried to throw you off there by adding an extra category, but right here, they did not sell any of the expensive cocoa. So as soon as I saw that, I crossed it out, and we were left with hardwood and pine bark. So hardwood plus pine bark equals 176 bags, and then the cost of each bag to get to the total of $5.20. I then multiplied by -2.75. It would have been just as easy to multiply by -3.5, so that would have been fine too, to get 48 hardwood bags and 128 pine bark bags. Today we're starting the last section of chapter 9, 9.5. We already graphed one linear inequality. Now we're going to be graphing a system, which means instead of 1, we'll be graphing 2. But the basic steps still apply here. So the first thing you're going to do is go through your explore activity, and then answer the reflection questions, and then we'll go back through this and you can check your answers. So take a few minutes to do part A, B, and C and your reflections. and then unpause this when the class is ready to check and move on. So for part A, to graph the inequality x plus y is less than or equal to 4, hopefully you solve for y. So we would subtract x. So it would be y is less than or equal to negative x plus 4. To graph that, that means we're starting at 4 on the y. And our slope is a negative x, so that means a negative 1. So that means down 1 and to the right 1. And down 1 to the right again. Hopefully before you graphed it, you checked if you needed a solid or a dotted line. This one was solid, so if you forgot to check, you probably got lucky here. And now the question is, do I shade above that line, which would be up here, or do I shade below it? Remember, if you forget how to check, how to look at it, you can always check a test point of 0, 0 as long as it's not on the line and plug that in. So if you were to plug in 0, 0, is 0 less than or equal to, well, negative 0 is just 0 plus 4. Yes, 0 is less than that, so you are shading below. Go ahead, if you have different colors, you could do that. I'm doing pencil markings, probably some of you saw what happened here. So the question was, did you shade above or below? And we shaded below. Well, now we're going to take the second inequality and graph that one. So first step, we still subtract x because it's a positive x. So now I have a negative y is greater than or equal to negative x plus 2. Are we allowed to have a negative y? The answer to that is no. So you should have divided by negative 1. But this is an inequality, and when you multiply or divide by negative, that inequality sign flips. So it should become y is less than or equal to a positive x minus 2. So we start at negative 2. This time my slope is a positive x, that means up 1 and over 1. Up 1 and over 1. Again, hopefully you checked solid or dotted. This one is again solid. So now I look at my inequality sign, which is less than, so that means to shade below. So we'd be shading below the line. Again, if you forget how to check that, you can check a test point. Is 0 less than or equal to 0 minus 2? The answer to that is no, so I can't shade where that is, so I have to shade on the other side. So we shade all this region. And again, we shaded below. And it said to look at the region where the graphs overlapped and to choose 3 ordered pairs from that region. So for mine, I'm looking for this red and blue. If you use 2 different colors like red and blue crayons or pink and blue highlighters, yellow and blue, that area will turn a different color and makes it really easy to see. So 3 ordered pairs, yours might not be the same as mine. Heck, they might not have been the same as your neighbor. I'm going to go 4, 0. And I'm also going to pick 4, negative 1. And then I'm going to pick 2, negative 2. Now, technically, yes, you could pick a point that's on the line since they're solid, but we really don't want to do that. We want to pick it in the shaded region. So anything that's in that where my red and blue are crisscrossing. So we plug them into both inequalities to see if they are true for both, because that's the whole point of having a solution. So for the first one, 4 plus 0, is that less than or equal to 4? It might not be less than it is, but it is equal. So far so good. And does 4 minus 0, is that greater than or equal to 2? And that's yes. So I'm going to put little check marks here. So that point worked. 4, -1 is 4 plus -1 less than or equal to 4. Yep. And 4 minus -1 greater than or equal to 2. Well, this would actually be a 5, so yep, that's greater than or equal to 2. So third pair to check is 2 plus -2 less than or equal to 4. Yep, because it would be 0. 2 minus -2 greater than or equal to 2. And that's another yes, because that would become a 4. Okay, so that was part C. So part 1 says, or reflection 1 says, that if you test another ordered pair where it overlaps, would it satisfy one, both, or neither? Hopefully you recognize that it would satisfy both, because it is a solution. The overlapping region shows solutions for both. Okay, so an ordered pair that makes a linear inequality true is a solution. What can you conclude about the ordered pairs in the region where the graphs overlap? They are solutions for both inequalities. To solve the system of linear inequalities, we're going to do exactly what you did through the Explore activity. You're going to graph each of the linear inequalities, and the solution are the ordered pairs that make it all true, not just the first one, but the first one and the second one. So here is an example that they've worked out for us with another visual of a graph. The first inequality is greater than, so notice that they use the dotted line, not a solid. The second inequality has the equal to part, so there's your solid line. They used 0, 0 as their test point. So 0, 0 was not true for the dotted line, which is why they shaded above it. But 0, 0 was true for the solid line, so they shaded below it. Your answers are going to come from this region where the two colors overlap. One thing you can do to help yourself a little bit easier if you'd like, you can get, again, those two different colors that if you mix them together will make a third color. In step 4, they've given you 4 points to check to see if it would satisfy those two inequalities. But again, keep in mind the entire point is to solve it by graphing. So you're looking for any solution that's in this region. But let's go through their table here. If you have 0, 0, 0 plus 2 times 0, is that greater than 2? And that's a no. Negative x, which would be negative 0, which is 0. 0 plus 0, is that less than or equal to 4? That one's a yes. But even though it satisfies one of them, is 0, 0 in the region where it overlaps? And the answer to that is no. And that makes sense because it's not a solution for both. Two, 3, well, 2 plus 2 times 3, is that greater than 2? And that's going to be a yes. When I plug it into the next inequality, that 2 becomes a negative 2. Plus 3, is that less than or equal to 4? That's a yes as well. Is 2, 3 in the shaded region where they overlap? Here's 2, here's 3. Yes, it is. So it makes complete sense that that would be true for both of them. So 2, 3 would be a solution to this problem. We're going to skip the rest of the table because hopefully that made sense to you. Number 3 and 4, how does testing specific ordered pairs tell you that the solution you graphed is correct? Go ahead and answer that, and then also go ahead and do number 4, and then unpause this when you're ready to check. So on number 3, testing specific ordered pairs, because they have to be true for both. So if they are true for both, they would be in the overwrapping region. And is -2 a solution of the system of inequalities? Well, the first inequality was your x plus 2y is greater than 2. And the other one was -x plus y is less than or equal to 4. Well, when I plug in -2, and then 2 for the y, -2 plus 4, is that greater than 2? It's equal to 2, but we need it to be greater than, so no. So is it a solution? No, because it doesn't work for both of them. Since it didn't work for the first one, you didn't even have to check the second one. So here's one to graph. So let's go ahead and do this one together. So x minus y is greater than or equal to -1. So the first thing I'm going to do is solve that inequality for y. So I'm going to subtract x. So I have -y is greater than or equal to -x minus 1. Now that y is negative, which means we're not done yet, so we have to divide everything by -1. And since these are inequalities, remember, every time you multiply or divide by negative, the inequality sign has to flip. So it changes to less than or equal to. My x turns positive, and so does my 1. So this means we have a starting point at 1. Slope of x means there's a 1 there, so 1 over 1. Before I connect, let's double check. It is a solid line because it has the equal to part. And now I check to see if I shade above or below. Looking at my inequality, the inequality sign has become less than, and this is why you can't shade until you have y by itself. So I'm shading below the line. It should be everything down here. My second inequality already has y by itself. Its y is greater than 2. We learned back in an earlier module, whenever it's just a y, that means it's a horizontal line. So I go to 2 on the y. Before I draw that horizontal line, I need to see if it's solid or dotted. Since it does not have the equal to, that means it's dotted. It says greater than, so that means I need to shade above it. So if we were asked to find solutions, we're talking about this region here, and then if your graph were bigger. To check your answer, you could take any point from there and make sure that it meets both inequalities. Now this next part, we're still going to graph it the exact same way we did the last couple, but here we're going to talk about parallel boundary lines. Now when you have parallel lines for a system of equations, then you always have an answer of no solution. But with a system of inequalities, it depends on the shading, so it does not always mean no solution. If you graph your two parallel lines and you shade above one and below the other, and there's nothing that overlaps, this whole white middle area is white, nothing here overlaps, nothing here does, then it's no solution. Example B shows you one way that they can overlap. You shaded above both lines, so the region that they have in common is actually this part above the second line. So this one does have solutions. The third is when it's shaded in the middle. So this one also has solutions. So again, the only time with inequalities that parallel lines mean no solution is when the shaded regions don't overlap. So we're going to go ahead and move on to the next problem. So I want you to go ahead and graph number 8 and then describe the type of solution you think that it has. Then unpause this when you're ready to check your answer. The first inequality, we need to go ahead and solve that for y. So x minus y is less than -1. So you should have subtracted x. Negative y is less than -x minus 1. But you can't leave a y negative. So we divide by -1. And again, that means your inequality sign needs to flip. It's greater than a positive x and now a positive 1. To graph that one, means we have a y-intercept of 1. The slope turned into a positive x, that means up 1 over 1. And before we connect it, double check is it solid or dotted, and this one is a dotted. Looking at our inequality at the end, it said y is greater than, so that means we need to shade above the line. So now we look at the second one, which is x minus y. Again, it's x minus y is greater than or equal to 3. We have the same start, we subtract x. And I have negative y is greater than or equal to -x plus 3. Divide by -1. So y becomes less than or equal to positive x minus 3. Well, we can look at the two inequalities and see that the slopes are the same. So we know our lines will be parallel. We just don't know for sure that that means no solution. So -3 is our starting point. Positive slope, up 1 over 1. It's got the equal to part, so this time we have a solid line. Now my inequality says less than or equal to, so we need to shade below the line. So since none of the regions overlap, this one did have no solution.